Hello everyone. So today we are going to see how to perform the shear parameters by direct shear test. So you can see here, this is the dial gauge, this is the proving ring reading. So this is the dial gauge and this is the experimental setup you are going to see here. Loading device, grid plates, porous stones, shear box 60 mm square and 50 mm deep. Okay, so you can see here, this is the overall setup of the shear strength determination of the soil using direct shear apparatus. So it is very useful for the design of foundation, retaining walls, slab, bridges, pipes, sheet piling. So the direct shear test used to predict these parameters quickly. Okay, the laboratory report covers the laboratory procedure for determining these values for cohesionless soils. So you can see here two readings. One right side, it is this one, and you can see here this is the shear box of 60 mm square and 50 mm deep. So now we need to place the soil sample in the shear box and to determine the water content and dry density of the soil compacted. So you can slowly place the sample of soil into the shear box. Okay, slowly we should place the soil sample, and you have to press with fingers to consolidate the soil slowly one by one. You can see here the soil is compacted slowly. With the help of finger we can consolidate the soil to determine the water content and dry density of the soil. So we should make any necessary adjustments for applying vertical load, for measuring vertical and lateral movements and measurement of shear force. So we should apply load on the specimen, keeping constant during the course of the test. For consolidation, for a longer period without shearing. Quick test, apply the shearing without consolidation soon after placing the vertical load. So you can see here, the soil is placed in the shear box of 50 mm and 50 mm deep, and we cover the cover plate. Okay, cover the cover plate. While applying the load, the soil could not be excavated. So here you are using Columbus equation for computing the shear parameters for clay soils, for sand. Okay, so now we should place the shear box after the proving ring and the dial gauge reading. You can see here, slowly we should place the shear box. So this is the dial gauge, we should make to 0, 0. This is the proving ring. So here we should apply the load. You can see here. So this is the dial gauge. We are rotating. This is the proving ring reading. This one. Now apply the load constantly, that the reading that is going to be changed in the proving ring and the dial gauge reading. So you can see here it is connected to shear box. The proving ring is connected to shear box.
2.6 50. 4.6.
You can
4.6.
see the reading is changing here
50.
in the dial gauge.
5.4.
You can see the needle is rotating in the dial gauge reading
6.
slowly.
6.2.
So simultaneously we should note down the
6.4.
proving ring reading, that is force applied, and the vertical dial gauge reading
50.
6.6. 6.8. 7.
So continuously we should note down the reading, dial gauge reading, by rotating the
7.2.
so readings we should
7.2.
take, that is proving readings
7.2. 7.2.
50.
okay.
7.2.
50.
So after that we have to stop applying the load, so the dial gauge needle reading will stop, and now you can see the shear box. We should remove the shear box, cover up the shear box. And after reviewing, we should split the samples by slab wise, and we can determine the angle of friction that is going to be calculated, showing the type of sand as densely coarse or fine. So you can see this is the sample obtained from the shear box. So in the next part we can discuss regarding the calculation of that. Okay, part 2 will includes the calculation part, including the readings taken from proving ring and this one dial gauge reading. Okay, thank you.